This is I think the last problem in this homework set for 2.2. It says find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. And we have y equals x to the fourth, y equals 1, about y equals 2, excuse me. And so when I first did this problem, I got a little frustrated because I just didn't think all the way through. So let's go ahead and come up with our shape. And this is probably where I made my big mistake. Is the shape. Well, it's not probably. I went with the shape. So I have my x to the fourth. This is a curve like that. And then y equals 1. We'll call this 1 here. And then here's our y equals 2. And so I was thinking, okay, this region is going to be rotating about this line. But it's really this shape. This comes over to here. So we're really going to be integrating from -1 to 1. Or we integrate from 0 to 1 and multiply the result by 2. And that's the real trick that I ran into here. So the other part is to come up with our representative rectangle. As if you watch the video, they show having a rectangle there. And you have your outer radius, your big R of x, and your inner radius, little r of x. So in this case, coming up with the outer radius is a little bit confusing, but we think about how far is this curve. Like think about right here, how far is that curve from this line of rotation? That's a distance of 2. If we think about here, how far is it? The distance of 1. Well, what's affected that? It's this x to the fourth. So I'm going to say my r of x is going to be 2 minus x to the fourth, because the thing that's making that distance less is the x to the fourth. And then my inner radius is actually pretty straightforward, I think, because we have a horizontal line and a horizontal line. Those are fixed distances, and that's just going to be 1. So we'll be looking at the integral from -1 to 1 of, I'll put the pi out here, of 2 minus x to the fourth squared minus 1 squared. And then our dx, you have a dx, and this, the width is delta x, of course, and that's our dx. And because this is symmetrical, I think it's not a bad idea to consider this to be 2 pi times the integral from 0 to 1 of 2 minus x to the fourth squared minus 1. And I'll just keep going with this then, 2 pi integral from 0 to 1. Why do I like that? I like it because putting 0 in there is a lot easier than 1, but probably really doesn't matter that much. Whatever works for you. So we have 4 minus 4x squared, plus, no, not squared. Someone's yelling at the screen probably. 4x to the fourth plus x to the eighth minus 1. So that's going to give us 2 pi integral from 0 to 1 of 4 minus 1 is 3 minus 4x to the fourth plus x to the eighth dx. And so we end up with 2 pi times what? That's 3x minus 4x to the fifth over 5 plus x to the ninth over 9 from 0 to 1. So 2 pi times what? Put the 1 in there. 3 minus 4 fifths plus 1/9 minus, and if I put 0 in there, those will all be zeros. So they give us a nice decimal, and I say that sarcastically. So when I put this in the calculator, I multiply by, all this by 2. I end up with the answer, which is 14.52113938. And that's what they're looking for. Okay, I hope that helps.